this video, we'll be continuing our first-person character controller in Unity. We'll be focused on making the player move in this video, so by the next video, we'll have the first-person aspect completed. Without further ado, let's get coding. Open up the Unity project from last time. If you do not have it, make sure you follow the first tutorial in my series. Now, you can see that our aspect ratio is set to free aspect, but if we move to another device, our aspect ratio could be messed up. So to fix this, let's set our aspect ratio to 16:9 aspect. That's better. Now the next thing we have to do before we can code is go to the character controller script and remove it from the player's components. The reason we need to do this is we're going to be making updates to the player, and we don't want to add the character controller script just yet. Okay, now we can start coding. Open the scripts folder that we made and open character controller script. Now Visual Studio should open, or it should open your preferred script editor. Okay, now that it's open, you can see that in the last episode, we created a few variables. In this video, we're going to use these variables by coding in the start function. Now, the start function runs whenever we start this scene by pressing the play button. So, it only runs once when we run the project, and only once. So first, let's call the rigid body variable and set it to getComponent rigid body. Now we can access this rigid body component. Now the reason we don't need to do player.getComponent is because this script will be attached to the player later after we make some edits to it. So right now, just set it to getComponent rigid body. Now that we have rigid body accessible, let's fix an issue. So right now, since our player is a capsule, our player is round in the collider. So if we move this player at high speeds when it's moving, it could fall over. So to fix this, we set RB, the freeze rotation, to true. This freezes the rotation of the player so it cannot rotate while moving. Now we're done coding in the start function. Let's move on to the update function. So the update function runs once per frame. So after we press the start button, it keeps on running. And so this could give some problems for us because we have to be careful with the update function. Because someone with 60 frames per second could be running this update function 60 times in 1 second. However, someone with 30 frames per second can only run it 30 times a second. So, that could give the person with 60 frames per second an unfair advantage as they are constantly running the movement script. And they could be able to move faster and be more aware of what's happening. Whereas the person with 30 frames per second performance will slow down. So right now, let's just create a function and I'll show you how to fix the update problem later. Call this function player input. Now right now it's giving us an error because it's not created. I'll show you a trick to create a function without writing anything. We just have to hover over this player input function, click on the little idea button, which is the code suggester, and then it should say create method player input. Now see, it gives us the code to create a function. Now you have to be careful of this because it might not always get the data type right. But right now it did because we want void, which means no return. Now delete this line of code it created because this line of code just means that it's not being used yet. So because it knows that there's nothing else in the function yet. But we are going to add some stuff. Now, let me show you something. Go to Edit, then Project Settings, then Input Manager. Now, show the axes, and then go to Horizontal. Now, you see it gives all the data about the horizontal axis, but the real important stuff about this are the buttons. The buttons control the horizontal movements. You can see left, right, A, and D, like W, A, S, D, and the arrow keys. Now, so this is going to power our movement script. Now, if you want, you can set the type to something else than key or mouse button, like joystick axes and mouse movement. But right now, just keep it to key or mouse button because we don't have to do that yet. Now, if you open the vertical axis, you can see something similar. Down, up keys from the arrow keys and the S and W keys from the W, A, S, D keys. And again, there's the type thing. Now we can just close all of this and let's get coding. So now that you saw that, you can understand this code a bit better. You see that we made these two variables, H input and V input, for horizontal input and vertical input. So let's assign them a value. Set H input to input dot get axis. Now, here you can see that you could do get axis or get axis raw. Now, get axis raw is for very precise movement, as when you're moving, when you stop pressing a key, it sets your horizontal movement to 0, so you'll immediately come to a stop. Now, get axis slows down to give you more of a realistic feel, as you're slowly slowing down when you stop pressing the arrow keys. So you can decide which one you want to do. But for right now, I'm going to decide to do get axis to give it a nicer feel to it. However, for extremely precise movement, like in platformers, you might want to use get axis raw. Now, let's put two quotation marks and type horizontal. Make sure it's exactly the way you find it in the axis, because it has to be like that so it can access the axis. Now, let's do something similar for the vertical input. Set V input to input dot get axis or get axis raw, and then type in quotation marks vertical. Remember, make it exactly the way we found it with a capital V. Okay, so now our movement system is ready to get input keys. So now let's fix this update problem. Create another void function called fixed update. And this is how you create a function manually. Now, so fixed update, make sure that the frames per second is the same for everyone, even if they have a higher frames per second than someone else. So it runs the same amount of times. Now let's create another function called move player to actually move this player. So you can see we could also do the trick we did earlier, but I'm just going to create a function the normal way. Now the reason we want move player in a fixed update is because we want this script to be fair. Okay, now I'll show you how to create it. So it's like creating variables. You have to make a privacy type, then a data type, then the name of the function, which we already decided. Now, instead of the data type in functions, we actually have the return type. So void means return nothing to the person who runs the function. Okay, then put two curly braces and we can start coding. Now here we're going to access our vector 3 and our transform variables. So let's type direction and then set it to orientation dot forward and then times v input plus orientation dot right times h input. Okay, now let me explain this code a little because it has quite a lot. So right now we have direction, which is our vector3 variable, and our orientation, which is our transform variable. Now what our vector3 variable does the north of the world, like how we have a north, east, south, west, and the north is always in the same direction. The vector3 follows the north of the world. So even if you're facing east and you press the W key, you will move to the world's north, not your north. And that could be bad because if you're facing to the side and you press the W key, you could be moving to the side. So that's why we need to add the transform, because the transform makes the world your north. So whatever direction you're facing, when you press the W key, you will always move in the north that is in front of you, not the world's north. And then so basically this gets the H input and the V input and multiplies that by the orientation of forward and the orientation of right. Now we only have to say forward and right because forward, and if the V input is negative, we move backward. And if the H input is negative, we move left. Now let's do RB.add force because we're adding a force. And then say direction in parentheses as a parameter that we're adding to the rigid body force. And now, the problem is, if you know the Pythagorean theorem, you know that if we're pushing the W key, we move one up, and the D key, we move one right. But what if we press the W and D key? Then with the Pythagorean theorem, it would be a squared plus b squared equals c squared. So if we're moving 1 squared plus 1 squared, which is 2, 2 is c squared, which is the amount of movement for W and D key. So then we move with the speed of square root of 2 when we press the W and D key. And we don't want this to happen because we want the same speed for all 8 directions. So what we have to do is we have to just type direction dot normalized. Now this makes sure that in every direction we have the same speed, and it makes it go no more and no less than 1. And then now do times speed, and then times 10, just to give it a little faster speed. And then let's add a new parameter by adding a comma, and then say force mode dot force, and then we can see 4 different force types. Now we want to use force because it's the most physically accurate force because it moves the speed based on the mass of our player, which is accessible through the rigid body. Now let's save this and let's go to our Unity editor and let's press play. Okay, so right now we can't exactly move the player. We have to edit this player because first we have to add the character script Wait, actually, no. I'm sorry. First, we have to remove this and name this player to module, and then right click on it and say create empty parent, and name this game object player, and then finally create another game object called orientation, and then add the character controller script to the player parent game object. Now let's create the orientation game object and make it as a child of the player parent. Okay, so name this orientation and drag it under the player. And now we're good to go. We can just set the orientation to the orientation of the game object player and finally run this. Okay, so, and we still can't move. Now, first we have to add the component rigid body. It says that there is no rigid body attached to the player game object. So we just have to set this. And you see our Y is moving, but we're not actually moving. So let's see. Oh, let's set the mass to 2.5 and the drag to 4. These are the preferred settings for me, by the way. And then remove the rigid body from the module. And we still. Okay, so this is weird. Let me try to find a solution for this. Oh, I know why. Our player script has actually not set a speed. So we have to just go to our player and set the speed to, let's say, 10. Okay, now our player should be able to move. And you see it can. Okay. So, now that we've got our player to move, in the next episode, we'll be making a script for the main camera and setting it for a player camera so that our player gets a 360 view around themselves. Now, so you can test the movement for a little longer if you like. You can see. But after this, we are going to create a camera controller script. So right now, we're just going to create the variables for the script, kind of like how we did for the character controller script in the first episode. And then later, we're going to create the entire script. Okay, now that we're done, we can create a camera controller script and then open it up. Okay, now Visual Studio's loading, and it should open in some time. And it's open. Okay, delete these comments, they're useless. And now we have space to start writing our variables. So the first variables are going to be serialized fields. If you don't know what these are basically variables that let private variables be seen in the Unity editor without being accessible by other scripts. So create a serialized field in square brackets and make it a transform and say camera position. I'll just abbreviate to camera pos. Now, serialized field, make another transform, but not camera rotation. It's actually going to be called It's going to be called orientation. And then we are going to create another serialized field and a float called X sensitivity, which I'll abbreviate to X sense. And now just copy this, paste this, and float Y sense. Okay. Now we just have to create a private variable that's not a serialized field, and a private float called X rotation. And we can even create another variable on the same line by just putting a comma and then saying Y rotation. Now this doesn't work for serialized fields though, because then we'd have to basically copy this and put on the same line, so it wouldn't be really coding the same thing in one line. It would be two lines put on one same line. Now save all of this. So you save all the scripts and go to the Unity editor and save this too. Thanks for watching this video. I hope you found it informative. Let me know what you thought of it in the comment section below. Be sure to subscribe to my channel and click on the bell icon so you never miss on a video. Have a wonderful time!